Hi everyone, welcome back. My name is Satish and I am an engineer in IT by profession. So my today's video is on Fibonacci series, which is a very common series and it is known to all of us who have studied or who are students of science, mathematics or computer science. So we all are familiar with this series. In Fibonacci series, what happens is a term is the sum of its last two terms. Here in this video, I'm going to demonstrate that thing, and I'll be implementing that thing in PowerShell. And there's one surprise. What a surprise in this video is, I will also show you the ratio of the current term to its previous terms. So you will see a pattern there. Okay, so let's start. Let me add a comment. Okay. So for that you have to you have to give the first two terms. Okay, first two terms of the start. The first two terms or the first they are the initial condition from where the Fibonacci series will start. The first two terms will be 1 and 1. Okay, the first two terms, and after that you will see that we will get the Fibonacci series. So the next term will be sum of these two terms. Okay, that is this will be the new term z will be the sum of these two terms. Okay. Now this will just give you one term only. So what if I want to find n terms, means the sum the value of the Fibonacci numbers till n values, or suppose first 20 values or 30 values, then how you can do it? For that I will be using a for loop. Okay, how to use that for loop? And I will be repeating this value, that is I will be giving the initial condition for the for loop here, and let it start from 1. Okay, so I'm going to repeat the loop till value 10, or I'm going to repeat the loop 10 times here. Okay, so now what will happen is it will calculate the value here, the next term, that is z, by adding these two terms, and then what will happen now at the when the second time the loop will run is, what will happen, it will assign the value of x, assign the value of y to x, and then it will assign the value of z to y. So when next time it will the run then when a loop will jump to a new term, then it will automatically find the last two terms. So that is why I am doing this thing. Okay, so by doing so we are ready, I think. Okay, so let's see what happens, what we get. Okay, and for this I will be mentioning this and this, then only we'll get the, sorry, first two terms here. So let's see what happens. As you can see, 1 1 2. Okay, so this 2 is sum of these two, 1 2, because these are the initial conditions. Okay, so 2 is the sum of 1 and 2, then 3 you can see the term sum of 1 and 2, then 5 is the sum of 2 and 3, then 8 is the sum of 3 and 5. So and so on, means you will see that this will repeat. Okay, so it will repeat till n values. So here it is 10. uh, as you can see that we have got this thing. Now the good thing is the thing which I was talking about. Let me write this thing here in the right host. Fibonacci number is this. Okay, so it will be it will look more more inform more catchy. So you can see here it is looking like this. Okay, um, these two are the initial conditions here. So you can write this thing here also. Okay, for now it is okay. Now, what is the good thing is what now I'm going to talk about the second thing, the ratio. Okay, what will happen if we let me first make a variable here where I will store this ratio. The ratio I'm talking is the current term to the previous term, which is y. So what will happen if I'll take the ratio? Okay, and let me describe this ratio here. Okay, so this is the ratio. So let us see what happens. I'll be starting with a very less number. Okay, very small number. I want the loop to repeat itself 5 times. So let's see what happens. You can see here the ratio is here you will not get any ratio because these are the initial conditions. So the ratio is 2, then 1.5, 1.66, 1.6, 1.62. What will happen if I increase this loop or the iterations? Now you can see the ratio is 1.625, 1.6153, Let us see what will happen if I again increase the ratio to 50. Oh, you can see this that this value is 1.6803939 1.680. So it is almost approaching 1.680. You can see. So it is almost approaching towards a fixed value. It means you can say that when the Fibonacci terms increase, means as the value of n or the as the value of the number of terms of the Fibonacci increases, okay, as the value of the term grows, okay, then the ratio of the current to its previous is a constant. And you know what this constant is called? This constant is nothing but it is called golden ratio in mathematics, and this golden ratio is found everywhere in nature. Okay, wherever there is symmetry, you will find this Fibonacci's number, and Fibonacci number as well as this ratio. Okay, this ratio is also found in the human body structure. This ratio is also used by the artists, to design or to bring symmetry in their paintings. This ratio, that is the golden ratio, is also found on the famous Mona Lisa painting by the Leonardo da Vinci. This ratio is also found in the Greek architecture. Okay, so this is everywhere. This ratio is everywhere. Fibonacci, this golden ratio. So it is a very famous ratio. I will also giving you some links of the this golden ratio so that you will have an idea then what it is. My task was here to just give you a brief introduction about the Fibonacci series or golden ratio and Fibonacci series. Okay, and how you can implement this thing here in PowerShell. So it is very interesting. Okay, and I will be mentioning this code in my description box. Okay, so you can copy that code and uh, use for yourself. Okay, you can use in any way you like. Okay, so this was all. And if you really enjoyed my video, if you want me to make videos, smaller videos like this, then you can please mention these things in the Fibonacci in the sorry comment. I'm sorry, in the comment box. Give a thumbs up, subscribe to my channel, and press the bell icon so that whenever I upload any new video, you will be notified. For more interesting videos like this, please subscribe to my channel. Okay, enjoy and have a nice time. Bye bye.